In this video, we'll be learning about a tool called a histogram. A histogram is a tool used to visualize the shape of a data distribution. This might be clearest if we just look at an example of how to make a histogram. So here's our example. Imagine that I have 25 pens and I recorded how many days each ink pen lasted before it ran out of ink. So here are the data, and I'm listing how many days for each pen before it ran out of ink and couldn't write anymore. These are kind of hard to look at for me, so I'm going to put them in order. Not the order I use the pens, but least to greatest. So now they're in order, and I can see easily that the data range from 65 days to 130 days. We're going to define bins first. Going from 65 to 130, I think if I make a bin size of about 15 days, that will be coarse enough for me to make a simple plot, but fine enough for me to see which pens are better than others. And my second step will be to sort the data into those bins. So first, let's define our bins. I'll have pens that lasted more than 60 days, but less than 75 days. And then pens that last at least 75 days. So you might see that 75 occurs twice. I need to decide where to put 75s. The rule we're going to use is we're going to have values up to, but not including 75 in the left bin, and then 75 itself will start in the right bin. Next, we're going to use lines to show how these data are partitioned into these bins. I see that this is the division between less than 75. Now I need the dividing line at 90. We need a dividing line at 105. And we need a dividing line at 120, which occurs here between 115 and 130 data points. The 3 there are going to come right down here into the first bin. Highlighting the next set, I'm counting 8 in this second bin. Highlighting the next group, we count 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. Add those to the table. Similarly, in the next group we have 4, and in the final group we have just 1 pen. Now that we've created our data table, let's make a little more space. This has already organized the data quite a bit. I can see that the largest number of pens last between 90 and 105 days, and almost all the pens last between 75 and 105 days. But I'd like to make this a bit more visual. So we're going to make some axes. On the horizontal axis here, we will plot the dividing values between our bins, and on the vertical axis, we will have a count of how many data points were in each of those bins. I see that none of my data are more than 10, so I've run from 0 to 10 on the vertical scale here, and from 60 to 135 on the horizontal scale. Now we simply make a vertical mark for our first bin, a horizontal mark at 3, here between 2 and 4. We've indicated the height of this bar. And we're going to fill in values for each of the additional bins, and then simply fill in those bars. And now we can see the overall shape of the distribution, making very visual that most of the pens last between 90 and 105 days, almost all the pens last between 75 and 105 days, and we see the full range of pen life over this time. There's some important points about histograms. One of them is that a histogram is not a bar chart, so let's look at what the difference is. You might say this looks like just a type of bar chart, but let's compare. Here's an actual bar chart. I took a bag of Skittles and counted how many of each color of Skittle were in the bag while I tasted the rainbow. I see that in my histogram, the horizontal axis here is a quantitative variable. This just means that this is a number. I can put it in an order. By contrast, with a bar chart, we have categorical data. This means that these are broken into categories, but there's no particular order that is the correct order for these categories. So that's the difference between a histogram and a bar chart. Also notice that the histogram doesn't have gaps between the bars. If we had some unrepresented value here, there would be a gap and it would indicate that there were no data points there. Another important point is that there's no best bin width. There's no best number of bins either. Each choice of those makes a difference in what we're seeing. So here's our original shape with a bin width of 15 days. What if we rebin that to have a bin width of just 10 days? Notice that these are exactly the same data, and this shows me that 8 of the pens lasted between 100 and 110 days, rather than 90 and 105 days. We still have a peak around the same location, and we have a gap now. There were no pens that lasted between 120 and 130 days. This sole survivor out here lasted more than 130 days. We could use even finer bins and bin these into every 5 days. Each of these graphs just shows us something different about the shape of the distribution of pen life. So in summary, a histogram is a plot of frequency versus a binned quantitative variable. It's not a bar chart, and it helps us to show the shape of a distribution, both its center, the most typical value, and how much it's spread out. and different kinds of binning show different features. So how might a company use a histogram like this? Well, they might investigate the machines that manufactured their pens and say, I noticed that all the machines that produced pens with short lives were machines 3 and 7, and then we might look into whether those need calibration so that they create a longer life of pen, or maybe we find that we'd like to sell more pens and the pens are lasting too long. So look into why are these pens lasting so much longer than the others. So these are often used in quality control processes. Up next, we'll be looking at how to make a histogram in Google Sheets.